If you watch this tutorial to the end, you will have a strong understanding of the fundamentals of coding in Python to be a football data scientist. To make it as easy as possible for this tutorial, you will not need to download any software, you will not need any special type of laptop with a graphics card or processing power. All you need is an internet connection and a web browser. These are the concepts we'll be learning with timestamps, and I would advise you to learn in this order, but feel free to skip around if you already know some of this stuff. But why should you listen to me? The truth is, coding did not come naturally to me. It took me a long time to learn, but because of the struggles I went through, I know exactly what the trickiest parts of learning are, which helps me to explain things simply. Now, I actually work as a data scientist in elite sport, so this is just me teaching you the skills that you need to do the same. First thing you need when you start programming in Python is an IDE. Essentially, an IDE is the software or the environment in which you will write your code. An easy analogy for this is if I wanted to write a book, I would need to write the book in some sort of software like Microsoft Word or Scrivener or Microsoft OneNote, for example. Words you would write are the equivalent to the code you want to write, and Microsoft Word would be the equivalent of the IDE in which you are writing your code. So the most popular IDEs for Python are VS Code, and it's what I tend to use, but there's also a few others like PyCharm, Spider, that sort of a thing. All of those are actually great, but think of it this way. These software are a little bit like Microsoft Word because you have to download them locally. And there are so many different versions of Microsoft Word with slightly different capabilities. So if I told you to download one of these onto your computer, it will lead to a few problems for you and me in this tutorial because firstly, something that works on my version might not work on yours if we do not have the exact same setup. And we run into that problem we all hate where something works perfectly in the demonstrator's code, but you just keep getting errors and you're just stuck. And the second problem is that running code locally means that you're depending on your own CPU power or GPU power, and that's when you'd actually need a decent laptop. Because code that works well on my high-end laptop might be too slow or even cause another computer to crash, so we want to avoid these problems. And how exactly do we get around this? Well, let's think back to our book example. Let's say I had a really unpowerful laptop that struggled to run even Microsoft Word. What exactly could I do? Well, I could just go to Google Docs, right? Because all that requires is an internet connection, and Google does all of the processing on our behalf. The great news is that we have an exact equivalent of that for programming, and we will both be using that today, and that is called Google Colab. So I want you right now to just navigate to Google Colab and open yourself the new notebook. And Google will now be handling all the processing on our behalf, which means that you and me are working in the exact same environment. So just a couple of things, because we are actually trying to learn here, I think it's better that we turn off all the AI assistant stuff. So I just tend to X this out. Then if you come into your settings, AI assistant, just untick all of those for now. So what we have open is called a Jupyter Notebook. And the beauty of Jupyter Notebooks is that you can organize your code into these nice little cells that you can see over here, where you can run each cell individually without running all the code that we're going to have below this. But that's a detail that you actually don't have to worry too much about for now. It's just something that's nice to know for this tutorial. Okay, great. So now that we're all set up, we can get into the actual coding, which I'm really excited for. Okay, so we're going to start off simple with something that you already understand without maybe even knowing that you do understanding, and that is called data types. And a data type basically tells Python what sort of information or the type of data that we're working with. And you might be asking yourself why they actually matter. And the truth is, you sort of already understand why they matter. Data types can help you know what you can or cannot do with certain data. And in many ways, they're the building blocks for everything coding related. So, for example, the number 83 obviously is a number, or more specifically, an integer, just known as an int in Python. So we can do certain things with the number 83. And actually, let's hop into Python so that you get used to seeing things in the context of code. So, like I was saying, each of these is what we call a cell. So for our example, we can just input code and whatever into these cells, and we could just hit play after that, and Jupyter or Google Colab rather will begin processing on our behalf. So just because it's the first run, it takes a little bit to connect, but should be done any second. With Jupyter Notebooks, the output is included here automatically so we can see what the result of this code is, so we don't actually have to put in a print statement. Because once you finish this tutorial and you're working in other IDEs like VS Code, if you wanted to see the output, you just put a print and then a bracket around the term and a closing bracket. So you would have to do this usually, and it's going to get us the same thing. But like I said, in a Jupyter cell, it always outputs the output anyway. But that's a very small detail that doesn't really matter for your learning right now. But just whilst we're here talking about functions such as the print, which just tells Python to display the result of the code, let's just quickly touch on one other very simple function, and that is called the type. What type does is simply evaluate the variable between the brackets and tell you what type that piece of data is. So if that sounds complicated, you'll see now that it's very easy because, like I said, you sort of intuitively know this. So if I put type and then 83, we already know 83 is a number, right? It's an integer. So it will give us the result, which is it. And if you weren't doing this in a Jupyter notebook, what you'll do is print, and then you'd want the result of the type. So you can see what the type of 83 is, and it will give you the same thing, integer. So like I said, knowing a data's type is all about knowing what you can do with it. So because we know 83 is a number, we know that we can do things like multiply. So you just use a little asterisk for multiply. You know you can multiply a number. You can divide it as well. Or you can even get the square root. And in Python, if you want to get a square root, you do a double asterisk and then 0.5. And you get your square root. So like I said, you already sort of know why you need to know a piece of data's type. So this was all about integers. And when you're in Jupyter, it's going to add a title. I just clicked text here instead of code. And then you add a hash. This makes it a big heading. And then that was all about ints. And then we can click off. And now we're going to be going into strings. So what if we're working with something that is not
a string, something which is more like a word? And here we have just that. So let's say instead of a number, we had the word dog. If we put the type in there, we will get str, which is short for string. So what you'll notice is to create a string, you have to put the quotes around the word, because if I just put dog, I'll get an error. What this error exactly is, we're going to get into that later. But if I just wanted to put the string dog, if I add the quotes, it works perfectly, right? So what exactly is the difference between what you can do with a string versus what you can do with an int? Well, you probably sort of already know some of this, because imagine if we had the word dog and we wanted to get the square root dog, right? We get an error, unsupported operand types between a string and a float. Do that between a string and a float. It doesn't even make sense, right? Or what if we were like, oh, okay, what if we tried to multiply dog times higher? Again, you can't do that with a string because it's not a number, right? But here's where things get slightly interesting with strings, because something you can do is actually called string concatenation. So that basically just means joining two words together. So if I have two separate words here, like, we'll do the classic hello, and I'll put a space here, plus world. Here you can see these are two separate words, but if I add a plus between them, they join together. That's called string concatenation. So it's a little bit weird in that way that you can do some math-looking operations on strings, but it's not really math, you're just concatenating them. Or at the same time, you could actually multiply a string. So you could do hello with a space times 5. And that would simply just give you hello 5 times. So that's just a couple of little nuances to know when you're dealing with strings. So hopefully you're now sort of seeing why it's important to know our data type, because if you don't know your data type and you try to do certain operations in Python which are not supported by that data type, you'll get a bunch of errors and you'll get really frustrated, which is what we don't want. So what are the major data types in Python? Well, what we care about are strings, integers, floats, booleans, lists, and dictionaries. And for now, we're only going to focus on these 4. And the good news is that 3 of these 4 are actually super straightforward, so it shouldn't take us too long to go through these. Okay, so for now, I'm going to start a new section, which is data types in depth. And we're going to be looking at ints and floats, which are quite straightforward. And basically, what they are, like we discussed, an int is any whole number, whereas a float, print, 5.8. A float is just another word for a decimal, essentially. So if we have those 2 numbers, and I'm going to copy paste them into here, I just want to confirm the type of each of these. And you can see we have an integer as well as a float. So now let's return to our example around strings, which are the most flexible of the data types. Not flexible just because you can do a little bit of string concatenation or multiplication. There are some important things to note. So for now, I've been using actual words, but something you should note is Python isn't a spell checker. So you can put literally anything that you wanted as a string and it would still be a string. Python wouldn't be like, oh, that's spelt wrongly, so it doesn't work. And something else that you can do is you can also actually include numbers. As long as it's inside the quote, you can include numbers within your string. So I could have a bunch of letters and a bunch of numbers mixed in there, and it would still work. So think about most passwords, which are a mixture of special characters, numbers, and letters. Those would count as strings. So now let's test your understanding a little bit. So before I run this, okay, what would we get for the type if I did this? You probably got that one right, which is 5, right? But what if I made this tweak here, and instead of 5, I made it 5.0? What would I get if I run that? That would then become a float, right? But now where things get interesting is I could take that exact same 5, and as long as I enclose it inside these quotes, what do I now have? Now it's a string because it's inside those quotes. So again, all of this should be fairly simple right now, and that's the whole goal. Right now we're just putting foundations in place so that later we can do the more complex stuff. So one last little test, I suppose, to gauge your understanding. So if I did this, what answer would I get? 25, right? But what would you expect the answer to be if I did this? Well, because now this is actually a string, we're just asking for the string to be repeated 5 times. Sort of like we did up here with hello times 5. All we've said here is repeat this string, which happens to be a 5 times. So that's why we get that answer. So you see we went through strings, floats, as well as integers pretty quickly because they are quite simple. And this is another simple concept, but it just has a somewhat fancy sounding name, which is booleans. And booleans are used to evaluate conditions. So basically whether something is true or whether something is false. So it's simple enough. And the notation to use a boolean is a double equal sign. So let's do a quick example to understand this. So let's say if I wanted to check if the number 1 is the same as dividing 2 by 2, right? Which it is, obviously. But if I wanted to check if these two are the same, what I would need is the expression or the data on my left and the data on the right, and we want to see if these two are equal. And how we actually do that is a double equal sign. So this is basically asking is what's on the left the same as what's on the right? And it will return true. So it only ever returns true or false. So if I change that to a 3, it now returns false. That's a Boolean. Is it true or is it false? That should be pretty straightforward as well. Great, we now know the basics of data types. And I know it seems a little bit abstract right now and maybe a little bit too simple, like who really cares about this? But what you now have in your hand is a brick. And you need that brick to start building your house and to start building your foundation. The next brick is actually really exciting because it's something that will be quite easy for you to understand, but it's also super powerful. So let's take a look at what exactly is variable assignment. So the formal definition. Variable assignment is the process of giving a value a name in Python so that you can refer to it in code. And my informal definition is that variables are like giving a nickname to a piece of data so that later on you can call that data by its nickname rather than having to write it all out again. And don't worry if you ever get confused, we're getting into examples so everything will be a lot simpler. And in Python, assigning a variable is super simple. All you need is the name that you want to give your variable and then your actual variable. And all you do is put an equal sign between them. So for example, if I was the manager of Inter Miami and for whatever reason, I'm the manager, but I'm writing my own code and I wanted to assign a player name, what I could do is just say player name equals Messi. So we've given it a nickname here. That's the nickname or the variable name. And here we have the actual variable, which is Messi. So now if I run this, every time below this, if I say player name, I don't have to type all of this out again. When I just say player name, Python knows that I'm referring to this variable that I was talking about earlier. It's a simple concept, but again, it's a brick that's going to get more useful and more complicated later down the line. So using this trick of variable assignment, I can also give my player other traits. So let's say I could say, my player name is Messi. I want to say age is 37. Height is, I don't know, 1.7, something like that. And if we want to use a Boolean, and we wanted to see if he played the last game, for example, we could say played last game equals true. So he did play in the last game. Let's say we already knew that fact. So you'll see you can't have a space in your variable name. What you need to use is an underscore instead, because I couldn't. So see, if I run this, there's no error. But if I try to do this, write it out like a sentence, you can already see it's causing issues. So that would be a problem. So you either need to use an underscore, or what I actually tend to do is do this and just use capitals to sort of separate the words. So now, again, my player name is already there. Age, if I just run that, I can get it. Height, get it. So the cool part is if, let's say a year went by and Messi got a year older and we wanted to reflect that, instead of saying 37 plus 1, what we would do is take our variable, which is already age. So we're saying his age now is his old age plus 1. So that means by using this nickname, we don't have to keep track of how old he was because that's already stored up here. So we just say whatever his old age was, add 1 to it, and that's our new age. So then we'll get 38. So let's make a quick distinction here. Do you remember how in our last module we talked about Booleans? And the example we had was 1 equals 2. And now we're still using equal signs over here. So the key to remember is when you use a double equals, what you're saying is you're asking a question to Python. Are these two things the same? So that's because we have 2 of these equal signs. But if we were to do this, we're making a declaration. We're telling Python. So a double equals is asking Python. A single equals is telling Python. We're telling it that these two things are the same. Okay, so that's why this gives you true or false. Are they the same, true or false? And this gives you whatever you want. So you're telling Python, hey, Python, listen, age is 37. I don't want your opinion on this. Age is just 37. So then when you then do call age a little bit later down the line, it gives you 37. So let's dig through a couple of things that might give you some issues if you're unaware of them during your coding journey. So let's say we had age 37, and then we asked for age. Okay, so here age was 38. So what do you think the age would be here? Well, it would actually go back to being 37, because what we've done here by declaring it again is we've overwritten everything else before it. This is like when you overwrite your own document. If you overwrite it, you overwrite it, right? So if you declare it below where it's already been declared, the latest addition is what gets saved. So if I then run this again, I get 38 because we said our age is 37 again. And then now here, we're saying it's 37 again, so it goes back to being 37. So that's the concept of accidentally overwriting your own variables. That happens a lot. You sort of want to avoid doing that. Well, not sort of, you do want to avoid doing that. If we had name equals Messi, like in our prior example, and then we look to print name here, what would happen? We would actually get an error. And that's because here we have a capital N and here we have a small n. So it is case sensitive. So if you have a capital, you need to have a capital when you're calling it. So that's why a lot of programmers would tend to just always use lower caps or lowercase, so that you don't have to worry about keeping track of, was this a capital, what was what, you know, that sort of a thing. So that's the reason why everything is usually in small letters. So again, a little test of understanding. Here, if we do name equals Messi, and then we do this, and then we ask Python what name is, what do you think we'll get? We'll get Ronaldo, because what we've done is the exact same variable name, so we've overwritten it. But if we do this, if there's a capital there, what do you think we'd get when we called name? Would get Messi, because this has a capital in it. It's a completely different variable. It's not the same thing. But below here, if we then call name, would get Ronaldo, because now we're referring to this with the capital, not the one with the small letter. So let's just talk about variable declaration order. Let's use new variables. Let's say we had Messi age here, and we wanted to print it. And then down here, so what did we say Messi's age is? Messi age equals 37. So what would happen if I look to do this? I would get an error. Messi age is not defined. And that's because, roughly speaking, Python reads from top to bottom. So it's coming all the way down here and it's saying print Messi age. And it's reading this first. So it's saying, wait, you've never told me what Messi age is. So it's not defined. So it can't print it because you put it below there. So you always have to make sure your variables are declared before you reference them. That would then work because you've told it Messi age means this, and then you've asked it to print Messi age. So right now you might be thinking, oh, if I have the string Messi, I'm perfectly happy to rewrite it every time rather than worry about declaring variables. But that's because we're still early in the process. The thing with variables is that they can refer to very long data types. And in Python, at times you have tables which are millions and millions of rows long. So if you did have a table that's millions of rows long, would you want to recreate that table every single time you wanted to reference it? Or do you want to just be able to say, table A means these millions and millions of rows? Or if the value we're looking at is pi, for example, would you want to rewrite the first 20 digits of pi every time you reference it? Or just define it once and then just use the variable name pi whenever we recreate it? So let's clarify this through an example. So I'm just going to copy paste some stuff to time. So if Messi had played 25 games, scored 30, assisted 15, and wanted to get his goal contributions per game, we could do this, right? And we could even quickly calculate what his goal contributions would be at the end of the season if he kept going at this rate for a 35-game season. So you can see there's a lot of numbers going on and it gets a little bit tricky. So what would be better is actually just to do this the first time, where we just define our variables, his goals, his assists, and the number of games he's played, and then we don't have to keep track of, oh wait, did I put the number here correctly? Did I put that number correctly? We can just use the actual strings. Sorry, you can just use the actual variable names. So what we would then get is something that looks like this. So now here's the really powerful part. Let's say he played another game, right? And he did not score, he did not assist. Using this old method without the variable names would have to go in here and say, no, that's 26 now. That's 26. That's also 26. That's 26. So you can see it's a bunch of changes. I've had to make 4 changes to change the numbers. And the thing is, if you had a lot of stats, there's a high chance that you might forget to update something and you end up getting wrong statistics. Whereas using this method, all I'd have to do is change it once and say, oh, he's played 26 times now. And everything else below that would update. So I hope you're seeing the power of it now. So a good way to think of variable names is sort of like a file name. If I had a Word doc here called dissertation, right? The file name is dissertation, it's just one word, but your computer knows that's like a variable name. And what you actually mean by dissertation.docx is the pages and pages of text that you spend researching. So now whenever you want to refer to all of those pages, you just say dissertation.doc rather than always have to write out the dissertation every single time you want to reference it. You can just refer to it by its file name instead. So now we're getting deep into the coding element of things because we're on to lists. And as a football data scientist, lists are one of the most versatile and commonly used data structures in Python. But what exactly is a list? Okay, so the formal definition is that a list in Python is simply an ordered collection of elements, and it can contain different items, such as numbers, strings, or even other lists, but we'll get onto that a little bit later. Okay, so that's the formal definition, but what exactly does that mean, simply put? Well, in football, you're rarely ever working with single items in isolation. For example, a team has multiple players, a player plays in multiple matches, and even in a match, a player performs multiple actions. So lists allow us to group multiple objects together, allowing us to do data science on them. So what exactly does a list actually look like? So just like other data types, it has a certain convention, like remember how for strings, we need to enclose them in quotes. For floats, there needs to be a decimal point, and for integers, it's just the numbers. Well, lists also have a special way of being structured. And the most important thing when thinking about lists is using square brackets. The square brackets begin the list, and commas in those square brackets separate the different elements in the list. So for example, if we're working at Manchester City and we wanted to have a list of all the defensive players from the starting 11, including the goalkeeper. Okay, so we would need the player names, right? So the square brackets open and close the list. And then player names, well, those are made up of letters, so they're obviously strings. So what we would have to do is, let's start with the goalkeeper. We'll put Edison in there. And now, if I moved outside of that, and then just look to put in, let's just say Walker, the issue here is that these elements are not separated correctly. You need to put a comma in between them so that these are separate elements within the list. And we'll get onto what you can do with those separate elements later, but this is just how it's supposed to look. So that would give us our list. And if we were to take the variable name and check the type, we get a list. So that's our very first list. So why would we actually want to use lists? So I'm just going to list the examples and you might not understand them at this point, but don't worry, we're going to break everything down. So the biggest advantage obviously is that you can have multiple elements within just one variable name, which is huge. And also they maintain their order. So no matter where I print this, it will always be in the same order of Edison, Walker, Diaz, Akanji, and Gvardiol. And it's also mutable, so it can be modified after its creation, which is also massive. And being able to have items of different types is also super crucial. So let's dig into these a little bit more in depth. So if we wanted to talk about storing multiple variables or items in a list, it could be anything really. So we've just given an example of multiple players, but it could also be the goals scored by your team in the last 5 matches. So it could be 1, 4, 0, 2, 3. And it could also be squad numbers, basically anything that you want. Now, coming back to the example of our defensive players, let me talk to you about one of the most powerful things about lists, which is because they maintain their order, right? So because they're always in the same order, Python is able to do something called indexing. So it indexes each of these elements in the lists, which simply means that it assigns them a number. Okay, so what exactly does that mean? Well, by indexing, it means each of these elements are assigned a number. So we're used to counting from 1, 2, 3, 4, but in Python, the first element is always 0 or at index 0. So that means Edison is at 0, he's at 1, 2, 3, 4. And that's very powerful because now, let's say we had, a list of 100 different players for whatever reason, and we didn't want to always have to read all of the names within that list, but we knew we just wanted to get the player who's at index number 37. Instead of having to look through the list and see who's at number 37, we could just directly query this list and ask it who's at index number 37, which is what we're going to look at right now. So we don't have 37 people, but following that same order, let's say we wanted whoever is at index number 2. So remember, we go 0, 1, 2. So instead of doing that, we could just go defensive players. And then what you do is square brackets and then the number 2. So we'll just assign it a variable and say index 2. Then we want to display that. Then that would give us Diaz, because it's 0, 1, 2. So that's why the orderedness of lists is super important. So that's super useful because let's say if you had the starting 11 of the team and you now wanted to split it into the defensive players, the midfielders, as well as the attacking players. Instead of having to retype everything like this, defensive players equals, Edison, blah, 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 blah. Basically just recreating this up there. What you could do is, it's going to be the first 4 players, right? Sorry, the first 5 players if we're including the goalkeeper. So what we can do is something called list slicing. So that means you can tell it to select the first 5 players. And how you do that is a colon and then the number 5. And that's because the number 5 on the end means stop right before 5. So stop at 4. So it will give you whoever's at index 0, 1, 2, 3, and 4. So 5 players, which is, it's weird, but you'll get used to it. We actually need to take this there. And we say from the tactical setup, give me the first 5. Then that will give us our defensive players. And then now what we could do is, again, we could go midfield players. And we can take it from that same ordered list. So we would still take our tactical setup, square brackets. But now, if you do this, this is the same as saying from index 0 to index 5. Get me the defensive players, right? But for midfield, we obviously don't want people at index 0, 1, and so on. We just want starting from index 5, so the 6th player. So what we would do is 5, so start from index 5 and go all the way up to index 8, because that will get you the 5th, 6th, and 7th player. And that will give us our midfield players. And then for our attacking players, we can do something very similar once again. So now we want where we left off, which was from index number 8. And here we can just leave this blank. If we leave this blank, it means just go to the end of the list. However many elements are left till the end of the list, just give me all of them. Just like here, we're able to leave this blank, which means just from the start of the list, give me everything until 5. This means from 8, give me everything until the end of the list. And that will give us our attack. And then now, if we want to maintain the sort of flexibility we have by cutting down the list over here, but still separate out the defense, the midfield, and the attack, what we can then do is do formation lines. And what we're about to do is creating a list of lists. So we can say we want our defensive players, which is this list that we've defined over here. We want our midfield players, obviously, after that. And we want our attack. Equals to assign it there. And now when you print that, you see we still have a list on the outside. So that's the opening bracket, and this is the closing bracket of our list. But all of these are now lists, as you can see down here. So they're now separated out. So we have a list of lists. So this is this first list over there, open, close. Second list, open, close. And that's the third list. Hope that makes sense. Now let's look at something interesting that we can do with lists. Again, it's building on what we've discussed before, which is accessing the different elements. So let's say we have our formation lines. And now we only wanted to get the midfield. So because this is a list of lists, these are 3 separate elements. So because there's a lot of different things in there, it looks like a lot. But if you remember what we have here, you can see it's actually 3 separate items. They just happen to be lists. And then within those lists, we have more things. So let's start off simple. If we just wanted to get the midfield, which is the second element, how would we go about doing this? Well, building on what we've discussed, we'll take our formation lines. And remember, we started index 0. So the defense would be index 0. But we want the midfield, which is at the second place. So it would be index 1, which is the midfield players. But here's the interesting thing. What if we wanted the third player within the midfield to directly be able to access Foden? So this is actually a good representative because you can see formation lines at index 1 gives us the midfield. So this is now technically just a list. And how do we access elements in the list? We just give them their assigned number. So this is index 0, 1, and 2. So what we're saying here is from whatever's at the first index of formations, which is midfield players, give me whatever is at the second index of that first element. Make sense? So now when we run this, we will get Foden. So that's the syntax here. So you're saying formation lines is these 3 things. From these 3 things, give me whatever's at index 1, which is midfield players. From what's at index 1, which is midfield players, give me whatever is at index 2, which is Foden. Let's discuss mutability, which simply put is the ability to be changed or edited after it has been created. So sticking with our example, let's say that was our back 4 to start off with. However, during the warm-up, our player at index 3, our left back, Gvardiol, got injured. How do we now change this list? And let's say it was Ake who came in. How do we now change that list to represent that? Well, we would simply reassign it. So we would say, okay, from our defense, we want to change what's at index 0, 1, 2, 3. So we want to change what's at index 3 so that instead of Gvardiol, who is now injured, we want to assign Ake to that position instead. And it's literally that simple. And now our defense list looks like that. So we replace Gvardiol. Go into the defense list, go to index 3, and make that Ake instead of Gvardiol. Pretty simple. But I'm sure you've used different apps that sort of keep you up to date with the scoreline of a match, let's say BBC or SofaScore, whatever. But so let's say these were the sequence of events in a match. We had kickoff, City in possession, Haaland goal, De Bruyne assist, high pressing sequence, Foden goal at 35 minutes. However, after a VAR review, this goal is actually ruled out. So we now need to change what this event says. How would we go about that? Well, we'll take our match events list, which is literally just that, and we want to get the most recent entry. So there's two ways of doing this. We could go, okay, that's index 0, 1, 2, 3, 4, 5. So if we said index 5, that would be Foden goal, 35 minutes, right? But another thing you can do is you can work backwards. So if you just want the last thing, instead of having to count exactly how many elements are in this, because sometimes, let's say there's been 48 different events in this match, you wouldn't want to count, okay, how many have there been? 1, 2, 3, 4, and get to 48. If you know it's the last occurrence that you want to get, all you do is -1. Because that means the minus means start from the back and then just go 1 backwards. So that would give you the most recent one. So that would still give you Foden 1. It's the same thing. So using our booleans, we can actually do this to check if they're the same. And we'll get true, because it is the same thing. But anyway, that's besides the point. So we want to change that last event to now instead say VAR check, the goal was disallowed. So we would do this, like that. And now below that, when we check what was the last event, the disallowed goal instead. So you can see how useful it is that we're able to pretty easily change what's in a list to represent what's actually going on in real life. So there's a few different functions that you can use to manipulate a list in Python, and you can see them just beside me now. I don't want to walk through each of these on this video, otherwise the video would literally never end. So these are just branch off topics for you to look into. Let's just look at a couple just to give you an idea of how these work. So for this example, let's say we were trying to build a FPL fantasy team. So what we would actually start with is an empty list because we have not selected anybody into our team yet. So if we were to display my team, we'd get an empty list because there's nobody in our team, right? So if we actually wanted to be a little bit more explicit, we could print this out. So we could say print, and you can actually add a string before your variable. So in quotes, I could say, this is what my team looks like. A colon and a space, and then I add a comma and then my team. So we're saying just print whatever is between these quotes, and then the comma, it means after this, print whatever is in my team. So basically that will now give us a sentence. This is what my team looks like, it's empty. So one of the most useful functions is called len, and this is actually just short for length. It allows you to check how long a list is. So, for example, what we could just do is len, open brackets, my team. And we'll get our answer, which is 0. It's 0 long because it's empty. So this is how a function works, basically. It's very similar to print, which is also another function. So you just put the name of the function, open brackets, and then whatever's being addressed in between there. Now let's actually start adding people to our team. Let's say we want to be safe and we want to get somebody guaranteed to return points in FPL. So what we can do is append. Append means add whatever I'm about to give you to the end of the list. So here, and append is also a function, much like print, length, and append itself. So we could say append Haaland, add Haaland to the end of my team. That worked. And then if we then print my team, now we have Haaland. So we have one person in our fantasy team now because we've appended them, we've added them to the end of our list. So now if I was to do this again down here, it's now 1 long because we've added 1 to my list. So I'll just copy paste. And basically, we could literally just keep doing this. And you see, it's just players that were appending, adding them to the list. See, so for all of these, I've included the price. So I should go back and do the same for Haaland just for consistency. Because at the moment, he's the only one without a price. So how would I go about doing this? I could restart all of this and correct Haaland over there, or we could use what we picked up earlier, which is reassigning an existing variable. So we could take my team, and Haaland is at index 0. He's the first one there, right? And then we could change that to be Haaland 13 million. Go. And then now, when we print that, he now has his price associated just like everybody else. So another cool thing we can do is we can double check what's already in our list. So let's say if we cleared all of these outputs and we didn't have access to this, and we sort of forgot who we had added to our team so far, and we're like, oh, have I already added Kane to the team? What you can do is just print something like this. So print, have I picked Haaland to start off with? And then a comma. And then here in the second part of the function, we're asking, is Haaland at 13 million in my team? So we'd expect a Boolean back, because whenever we use in, we're asking for a Boolean. Is this in this list? Yes or no? But if we're to do the same, if I was to copy paste the same and I was like, is Jackson at 8 mil in my team? Oh, so I should change this as well, actually. Then I'll get false. So that's just how the in function works. Is this element in my list? And you know how it is with fantasy teams. Sometimes your budget just isn't working and you decide you need to remove some players. You're like, okay, if I have Haaland and Salah, both pretty expensive, do I need Watkins or can I get a cheaper option? I think I can get a cheaper, better option. So I want to remove that last option. So now, here's where the issue comes. We could do what we've been learning. So at index -1, change that to be empty. But the problem with this is that it actually wouldn't completely remove the element because it would still be there, but it would just be an empty string over here. So actually, if we did length of team, it would still say 4 because it's counting 1, 2, 3, and this empty string is still counted. So we want this removed completely. And conveniently enough, the syntax is we'll just say my team dot remove open brackets. So remove is another function over here, and then we could copy paste what we want to remove over there. Run that. Oh, sorry. The issue is that I overwrote my own list. Okay, we need to start from up here again. Okay, run that. Okay, perfect. So now what we can do is my team dot remove Watkins at 8.5, and it's done that. And you see now at the end, we don't have the empty string. It's literally just the 3 remaining elements. So when we do length of my team, we get 3, which is what we're supposed to get. So let's say now at this index, at index 1, we wanted to add another element, another player. Let's say we wanted to get another attacker. Let's say we wanted to get Anthony Gordon. So what we could do is insert that player into the team. Let's say instead of adding them on the end, which is what happens with append, we want to add him with the other attackers here. Or actually here at index 2, just after the 2 forwards. So we would say my team, in my team, which looks like this, dot insert at index 0, 1, 2. So at index 2, and then a comma, I want to insert Gordon at, let's call it 7 million. And now That's what my team looks like. He's been added in. So in the resources below, I'm going to be including 2 more in-depth examples of a lot of the stuff that you can do with lists. I just don't want to get bogged down in the details, because when you're actually working in real life, oftentimes you'll have a reference that you can look at, so you don't have to memorize the syntax or anything. This was just getting you comfortable with a few of the ways you can manipulate lists, as well as how to use some of the built-in functions in Python. So that was everything about lists, but let's move on to something even more powerful, which is dictionaries. So on to dictionaries. What exactly is a dictionary? Well, actually, it's not too far off a real-world dictionary. With a physical dictionary, you'll typically have a word listed in bold and its associated definition next to it. In Python, we do sort of similar, except we're storing information and data in what we call a key-value pair. And the key is kind of like the word that you would look up in the dictionary, and the value is sort of like the definition. So in terms of syntax, this is how it looks. You'd first assign the variable, my dictionary. And now with lists where we had square brackets, here we use the curly braces, and we always have the key. So this time we'll name the key, and we'll name the value as a string. So what we have there is a dictionary, and we can confirm this by checking the type, and you'll see dict for dictionary. So you might be thinking that this seems like a good way to store data, but that's what we're doing with lists anyway, so why would we want to use a dictionary? Well, coming back to our code, if we had all the Liverpool players listed here, that would be great, and it works, obviously. And it obviously works as a list. However, how useful is this information actually? Because do we know anything about the multiple stats that a player can have per game? Like they can have goals, assists, cards, passes. Do we know how many minutes they played? And do we know the performance of any of these players? Or is what we have simply just a list of names? Okay, but what if your argument is the problem is the way that I set up the list? Because we could technically store this data if our list looked a little bit more like this. So we'd have our players, their respective passes completed, shots on target, and tackles won. So here, Alisson, 22 passes completed, no shots, no tackles, right? Hypothetically, yes, you could have something like this, but it creates a few problems. So, for example, if you want to reference a player's stats, you would first have to look up what index they are, and then try to relate them with the respective stat at the correct index as well. So technically here we could say, okay, if we wanted to get all of Gakpo's stats when he's playing as the left central midfielder, we could just do print Gakpo's stats, and then we would look for his passes and what index is he at. 1, 0, 1, 2, 3, 4, 5, 6, 7. So 7th index of passes. So let me just quickly explain something. Why I'm doing this. So this is called an F string, right? And what it allows you to do is pass a variable inside the string that you want to print. Because before, let's say we had wanted to print something like this, which is the number of passes completed, we would have had to do this. Passes, colon, space, and then a comma, and then done passes completed. 7, like that. But this allows us to do the exact same thing, but passes completed inside F string, it sort of acts like a placeholder. Like, give me whatever the passes completed here are. So this would give you the exact same thing. Makes a lot more sense when you're dealing with longer text. So like, let's say if I was writing a match report and I was like, and then say he completed, comma, and then put in our passes completed afterwards, then continue our sentence. And this was significantly higher than usual. That was paired with shots with, and then we'll have to put a space. What's on target 7 shots. So you can see it works, but it is very finicky to always have to put these commas and just like do all of that syntax stuff. So with F strings, what I would do, I'm just going to copy paste here. And the only change I'm going to make is I put an F in front of that. And then now I can make this all one big string. And whatever I put inside the curly bracket is going to be treated as a variable. So what Python is reading is Gakpo played extremely well and he completed variable. And then we can do that. So we're removing that closing quote there so that it's still all one string. And we'll also remove that and that one. And we'll then just put the curly braces around our variable. And it will give you the exact same thing, but it's just a little bit cleaner. I hope that was easy to understand. If not, don't stress. That's really not that important, to be honest. Anyway, back to what we were actually looking at, which is, yes, okay, so I could do that and then be able to print it, and we get all of Gakpo's stats, right? And it looks like it works, but what happens if this list of players here is assuming a 4-3-3, but what happens if they switch to a diamond mid-game and Gakpo is now playing at attacking midfield? Well, in the diamond, the attacking midfielder wouldn't be the 7th person. They'd be like the 3rd from last person in your list. So you would probably want something like Gakpo here and assume another midfielder came in like Endo, and Gakpo is playing at the attacking midfield. So now what that means is that all of this is wrong, because now we would be getting Endo's stats, who's at the 7th index, rather than Gakpo. So we're not associating any of the statistics with Gakpo himself, we're associating them with position 7. So the issue with that is that it creates a lot of potential room for error. So is there a way around that with lists? Well, if I copy paste this here, hypothetically, yes, there is, because now we have a list of lists. And we could say that, you know, each player is associated with a list of statistics, and we'll assume 1, 2, 3 are always in the order of passes, completed, shots, and tackles. Yes, that would hypothetically work, but let's say we wanted to get Cody Gakpo's shots in this game. It's a little bit finicky, because what I would have to do is say player stats. So now we're inside this, and then we'd have to remember that Gakpo is at index 0, 1, 2. So at position 2, which looks like that. Then we'd have to remember, okay, the stats are the 2nd element. So we'd have to put another 2. And now we're inside his stats. Position 1, because we're 0 indexed. So these are his stats, and we said we wanted to get his, let's say we wanted to get his shots. Then we'd also have to remember that, okay, within this, they're at position 1. Meaning position 2, and eventually we've gotten to Cody Gakpo's shots. So you can see how messy and finicky that is. The good thing though is with dictionaries, we can solve a lot of this. So with dictionaries, instead of using the position to associate data, we use the key. So like I was saying, with the key being the word and the data being the definition. So now instead of looking for position 7, which is very interchangeable depending on the formation and what have you, we could just look for his actual name being Gakpo. Let me give you an example of this. So we could create a player, and as always, we have our curly braces. We can go to the next line, that's fine. Even though it's now split onto 3 separate lines, whatever is in here is the same as being on one line like this, but it's just a lot tidier to have it on separate lines. So now what we can have is name, and we'll say name is Gakpo. So the key here is name, the value is Gakpo, and we can have multiple pieces of data associated. Position, we'll put him at left wing, though he's very versatile. Goals. Well, let's stick with our shots example. Shots on target. 2. And 2. Okay, and now the beauty is, if we actually just rename this to Gakpo Dictionary, since it only has his stats, the beauty now is that when we wanted to get his shots, all we would have to do is say print from Gakpo Dictionary. What we want to get is his shots on target, and would get the same thing. But now it wouldn't matter if we had a list of dictionaries. It wouldn't matter what position he was in. It would just be associated specifically with his data. We can just go in and get the shots directly. I hope that explanation was understandable. So you might be wondering, okay, that's great when we have one player, but what if we have a bunch of different players like we did in this list? How would we accomplish the same thing? Well, now, just like we can have a list of lists, we can have a dictionary of dictionaries. And how this would look is, let's say we wanted to get match stats for a bunch of different players. Would have match stats equals, and then would open our dictionary. And then now, remember the key is what we use to search. So for the key, we want to be able to search players by their name. So now what we could do is do this. First key is Gakpo, and then the value is the information that we want to associate. So because there's multiple stats, we can put all those stats into a dictionary themselves. So now, first stat is goals. And we can put, say he's on a hot streak, 2, 1, 3. And then we can put assists as the next key, in case we want to just look up this assists directly. There you go. So we have stats for Gakpo, Nunes, as well as Diaz. So if we run this, now let's say we want to get Diaz's assists. Instead of having to worry, okay, what position is Diaz in, if this was a list, instead of worrying what position is Diaz in, what position is assists in, oh, now we can finally get the assists. What we could just do is say, okay, print, we want to get from match stats, we want to access Diaz, and we want to get his assists. We already know what we're looking for. And as simple as that, we've now accessed the lists here. Okay, so what exactly is this syntax saying? Well, there are some similarities to lists, because what we're saying here is match stats. So we're saying go into match stats here. And remember, the key is what we use to look for our information. Just like in dictionary, you look up the word to get the definition. You don't look up the definition to get the word. So we are looking up Diaz. So to start off with, yes, it's a dictionary of dictionaries, but sort of just ignore what's inside here, like these other things. Pay attention to these curly brackets, because that's the key, and whatever is inside all these curly brackets for these three instances, that's the value, because it's a dictionary of dictionaries. So dictionary is like this, key, and then the value like that. This value can be an int, it can be a string, it can be a list, which would be like that, and then you could have a bunch of different things inside that. But what we have here is a dictionary. So we have a dictionary of dictionaries, which is why we then have a bunch of stuff within these dictionaries as well. But for this first stage, we're just saying, go into match stats, look for the key Diaz, right? And now that we've looked up the key Diaz, if I erase the actual assists, you'll see what it looks like. This is what we have inside the key Diaz, which is basically just all the values, so all the definitions of it. So to make things even easier for you, just a couple of very crucial methods or sort of functions that you can use when you're dealing with a dictionary. Let's say you had a bunch of data in here. Let's say you had 100 players in there. You don't want to scroll through this to see what you have available to you. So what you can do is just say from match stats, get all the keys. Remember key value pairs. So we could just do that, is plural, and it would tell us everything that we can potentially get. Just the same way that we can look up just the values from match stats as well. Although that is less useful in this particular instance because you won't know whose stats you're looking at exactly. Okay, so what we're covering to this point was primarily about understanding data structures and what have you. But now we're going to actually start doing some coding, which is changing the state of things. And a useful skill to know is called control flows. So control flows might sound complicated, but it's something that we actually do every day, even if we don't realize it. And I'll give you a couple of real world examples shortly. So for example, let's say this was you and you were getting ready to walk to work. If you live anywhere like I do, the first thing that you would have to do is check the weather. And what you'd want to check is it raining? So you're checking the weather to see, is it raining? And then depending on the answer to that, you now have two different routes that you would take. It could be more, but for simplicity's sake, we'll say it's just two. So if it is raining, what would you then do as a result? Take your umbrella. If it's sunny, what would you do? Go to work. You wouldn't have to worry about the umbrella. And then here, after you get your umbrella, you'd go to work. So that's essentially what a control flow is. So here, what we're checking, we're going to dive into this a little bit later on, but that's called an if statement. If a condition is fulfilled, so if it's raining, get umbrella. If raining is false, then just go straight to work. Okay, so why are control flows actually important? Well, they actually allow us to make decisions based on specific conditions like we've just seen. And this essentially gives you a lot more flexibility in how you code, as well as giving you the opportunity to make your code more efficient. So let's have a very simple example. Let's say we were trying to analyze a Manchester United player's performance, a striker, right? We would have their goals, assists, and their minutes. So to save time, let's say these were the variables we had. Then we can obviously get the assists per 90 by just multiplying by 90 and then dividing by the number of minutes, right? So let's say we wanted a very rudimentary way of checking if this player is an elite striker, a good striker, or an average striker. And this is just for example's sake. So let's say we decided, okay, an elite striker would have at least 0.6 goals per game. An okay striker would have around 0.4 goals per game. And if they have less than that, they're sort of average or even worse than that. So how would we be able to classify this player based on our control flows? Well, we will start with an if, because just like how in our weather example, we're checking if raining. So here, what we want to check is if goals per 90 is greater or equal to 0.6, then we will say their goal rating is that of an elite striker. So this is the syntax for an if statement. It's just the word if, then what you're trying to evaluate or what you're trying to equate, a colon, and then the result you would want to get below this. Okay, so let's start off simple. Let's say if they're over 0.6, they're elite. Otherwise, if their goals per 90 is less than 0.6, then we'll say their goal rating is average, right? So now if we run this, and then at the bottom, we put goal rating just so that our Jupyter cell displays. I'll just write the print function. It's a good habit. So we can see here the goals per 90 here was actually equivalent to 0.47. So that's less than 0.6. So that means his goal rating is average. But you see, there's an issue here. It's not just a player is elite or they're average. There's so many other conditions in between. So what if we just added more if statements? And then here we say, but if they're greater than 0.4, then we'd say they're a good striker. So what would happen here? They would be classified as a good striker, which makes sense because they're at 0.47. But what if we had an edge case where we wanted to identify a player who's very good, but not quite elite. And we said, okay, this player, if they're more than 0.45, we want to say that they are a high potential player. So we'll say their goal rating equals high potential, right? So that's what we should get, because 0.47 is greater than 0.45, which is also greater than 0.4. But watch what happens if we do this. We're still getting good striker. So why is that? So what we must always remember is that Python runs from top to bottom, roughly speaking. So what happened here is that Python checked, are his goals per 90 more than 0.6? No, they weren't. So this was no longer an option, and this was basically skipped. Then it checked, are his goals per 90 more than 0.45? Yes, because that's 0.47. So for a moment in time, his goals rating was actually assigned as high potential. However, like we said, Python is top to bottom. So we still ran this final check here, where we said, are his goals per 90 greater than 0.4? 0.47 is still greater than 0.4. So this goal rating here got overwritten here, which is why we ended up getting good striker. So how do we deal with multiple conditions? Well, let's talk about the elif statement now. So elif is short for else if, and that means that the condition below is only checked if none of the conditions above are satisfied. So let's say these were the ratings that we're using to identify our striker. I will just recreate what we had before just for simplicity's sake, 2.4. So why is it now that if we run this, we get what we actually wanted the last time, which is a high potential striker? Like I said, the condition only runs if the one below it is not satisfied. So what we're seeing here is that, remember, our player's goals per 90 were 0.47 something, right? So is that greater than 0.6? No, it's not. So because this condition was not satisfied, we still come to this next phase, the else if. Else if that is not true, let's do this. So we're now checking, is the goals per 90 greater than 0.45? And of course, 0.47 is greater than 0.45. So we assign the goal rating as high potential striker. So now, because when we get to this stage, this condition has already been satisfied, we no longer have to do this at all. So we can now just basically ignore all of this because that has been satisfied. Hopefully that makes sense, and now you understand what to do when we have more than one condition that we're trying to check. And just a quick note on the else statement. Else just means if none of these are satisfied, we'll do this instead. So instead of then just saying if goals per 90 is less than 0.4, you can just say otherwise if none of these are satisfied, then do this, because the only ones left would be less than 0.4. But sometimes a simple else elif flow isn't quite enough, because sometimes we want multiple if statements, because entering the first if statement might just be an entryway into the next if statement. Let's have a quick example to expand on this a little bit more. So let's come back to our raining versus sunny example. See, the thing is, what happens if it is raining? And yes, you could take your umbrella, but there's always another condition. Because if it is raining, I want to now check how windy it is. And that's because here with yes, here with no. If it's not windy, then fine, take your umbrella. But the issue is, if it's raining and windy and you try to get an umbrella, that umbrella is going to get blown all over the place. It's going to get flipped inside out, or whatever you call that. So if it's windy, we now want to take our raincoat instead. So now we have two if statements inside each other. So first of all, if it is not raining, just go to work. If it is raining, I want you to then check if it is windy. If it is windy, raincoat. If not, umbrella. Now let's come back and look at our attacking player. It's not always about just goals, because sometimes assists factor into it as well. So let's say in a single game review, so if they have scored more than one goal, We then want to check if they also have more than one assist. And if they have a goal and an assist, we want to say that's a great all-round attacking performance. But maybe they scored 2 goals instead of just the 1. So we want to then say great clinical finishing. Otherwise, in line with the if statement, if they scored but did not assist, we want to then say else, okay? But if they have no goals and they also have no assists, we then want to say, so our guy had 0 goals, 0 assists. So if goals greater than or equal to 1, nothing. So he goes straight away into needs to generally get more involved in the attack. If he has 1 goal, he moves into good goal scoring but needs to create because he has no assists. 2 goals, again, it's more than 1 but no assists. But if he has 2 goals and an assist, he has both a great all-round attacking performance and great clinical finishing because it's more than 1 goal, but at the same time more than 2 goals. But you'll notice we forgot to account for this situation where they have no goals but no assists. And that's because we did not set a condition of no goals but having assists. So what we would want here is to add an elif. So if this is not fulfilled, but his assists are more than 0, I want to then say 0 goals, 1 assist, gets compliments on the creation, but mentions that we need more goals. So let me just dig into this concept of indentation a little bit. So how does this exactly work? So in Python, indentation matters. So you can see that this if statement is not in line with this if statement, which is not in line with that one either. So basically, we always have an if else condition, like with our range check. So whenever an if is open, let's say in this line, in line here, its else will always be within the same line. So let's say you have an if here, you can have all the conditions in the world, but then if this first condition isn't met, so it doesn't go into any of these, then it will go into the else, which is in line with the initial if. So this if statement here, draw a line, in line with this elif, and that else. So basically, if this first condition isn't met, we jump into the else or the elif that is in line with this if. So immediately, if they don't get more than 1 goal, all of this gets ignored because that's indented further than this elif. So if this initial goals more than 1 isn't met, we're jumping straight into are their assists more than 0 at least. And then if that's not fulfilled, then we go into the else. And then the same logic follows inside here. So you see we have this if is in line with that else there. So once this is fulfilled, once they have more than 1 goal, we then check if they have more than 1 assist. If not, we then come straight into this else that's in line with that if. And each of these sort of layers is called indentation. How far in you are from the margin, essentially. And to do that, you literally just use your tab button or key, which I never thought I would use until I started coding. So that's how you indent tab. So you can have as many if-else statements inside each other as you want. They can keep nesting for as long as you want, but the ones which are in line with each other are always treated as the relevant if-else to each other. So let's return to this concept of a while loop. And a while loop is essentially a way of telling your program to repeat a set of instructions over and over and over again until a certain condition is true. It's like saying, keep doing this until conditions change, which is then your signal to stop. So let's say this is you, and you're getting ready to work, or to have some breakfast rather. So you decide to boil some water, and let's say you want it piping hot, so it gets to 100 degrees. And you want to make coffee, so you pour it into the coffee mug. And obviously when it's at 100 degrees, it's way too hot to drink. Let's just roughly say at 50 degrees is when it's safe to drink. So what happens is, let's say you put a thermometer in your mug, right? So a while loop, you're then saying, while the temperature of the coffee is more than 50 degrees, wait. And then as soon as it's not greater than 50 degrees, drink. So what happens is, you, which is the equivalent to your program later on, are consistently checking this thermometer. So again and again, you check, is it more than 50 degrees? Yes. Then wait. Then you go check again, is it still more than 50? Yes. So wait. Then you check again, is it more than 50? Yes. So wait. Then eventually, it will get to a point where after waiting and you come back, it's not more than 50. So then you now escape from this while loop, and then you'd come into the drink phase. You'd be able to drink. So that's what a while loop is, explained by a real world example. So let's turn this into a more FIFA example. So you know how in FIFA you have those player stamina bars? So let's say it starts at 100. But you want to make sure your player doesn't get too tired so that they don't get injured. So we'll have our minimum stamina is 60. So if it gets to 60, you want to substitute them out. So this is how you'd write that while loop. So you would say, while the player stamina is more than 60, print he can play. And let's suppose your player keeps playing. We would then just take player stamina minus 5. And we want to print. And we're simulating that 5 more minutes have passed. The player's stamina is now. And then we'll reach a point eventually where the stamina is no longer above 60. And we just want to say time to substitute. So if we run this, what you'll see is so I've actually made an error there and I'm stuck in an infinite loop. So why that happened is because I just said player stamina minus 5. So I need to reassign player stamina if we go back to our variable assignment so that the minus 5 actually takes place. So now let's rerun that. And there we go. So let's explain what's happening here. So initially, the player stamina here is actually 100, right? Which is why we get this first instant of he can play. So that's there. So that's that there. And then for our simulation, so we can actually simulate that the player's stamina is slowly coming down, we're saying, okay, we now want to subtract 100 minus 5. So the stamina is now down to 95. And then that gets printed here, down to 95, which is what we're getting here. So, like I said, the instructions will be repeated again and again. So in this while loop, it will then come back to the top. But now the player's stamina is 95. But we still are above 60. So we get he can play, and that's the second he can play here. Player stamina, we subtract 90. And then we get player stamina is now 90 here, this second time. And this loop keeps going because then, now that it's 90, we check if it's greater than 60. It is, so we get this third he can play. Subtract 5, it's 85, that comes there. And then this keeps going until eventually we get to the point where the stamina is at 65 after doing -5 a few more times. So it's 65. He can still play, which is that there, pretty much the last time that he can play. And then we subtract 5, and now his stamina is 60. So what happens is now we have one last check where we check, is it still more than 60? No, it's equal to 60, so it's not more than 60. So because it's no longer more than 60, the while loop is broken. So all of this gets ignored from that point forward. So we don't go into those conditions. We now just come straight into the else and we print time to substitute him. So now let's talk about what is called a for loop. Again, this is another way of controlling the flow of data within Python. So let's explain the concept of for loops through a real world example once again. So let's say you're getting ready for work again, and there are a few essentials that you need to take with you to work. So we'll just put those in a list. We'll say there's your laptop, charger, phone, keys, and your wallet. So what you want to do every day before you leave is check if your essential items are in your bag. So for each of these items, you want to check, okay, laptop, is it in my bag? Yes. Charger, is it in my bag? Yes. Phone, is it in my bag? Yes. So you do that through a for loop, which basically performs the same action on multiple items. So how we can easily show this to start off with is just by printing them. So if we say in Python, for I in essentials, print I. So I'll just do that here. Okay, so what exactly is happening here? For I is actually just a placeholder. You can use anything you want here. X would still give you the same result. If we said for X in essentials, print X, you can basically use whatever you want, but in data science, we just tend to use I. So this is like saying for item in this list. So for each item in this list, work essentials, do whatever is down here. So we said print. So what we're saying is for laptop in work essentials, print it. Once that's done, we go on to the next item, which is charger, we print it. Keys, we print it, and so on. So if we wanted to check if the items are in our bag, there would be a little extra layer there, right? Because then let's say we had a list with what's already in our bag, right? Let's say we only have our laptop, keys, and wallet in there. So now instead of just printing, what we want to do is for every item in essentials, we want to check, is it in bag? If not, and we want to alert if it's missing so that we can go put it into the bag. So how does that look in code? Well, we would then need to add what's currently in our bag, right? And then now, instead of just printing, we don't want to just print. So we're saying for, let's go back to I here. For every item in our work essentials, if that I that we're currently checking, not in. So remember how we used in earlier to check if our player was in our fantasy team. Now we're checking if an item is not in bag. So if the item is in work essentials, like charger, but it's not in bag, we want to alert ourselves that it's not there. And we'll use an F string again because we don't know what item it is. This is where you see the power of F strings. We can now just say, we can put in the I there between the curly braces, because now what that I is doing is whatever I we're working on. So it could be laptop or it could be keys, depending on the run. I is not in bag. E2 packet. Otherwise, so else, in line with this if, so if it is in the bag, we want to just print item is in bag already. So let's run that. Well, actually, instead of item, we'll put I so that we can see which item it is exactly. And here, to make things easier, I'm just going to print what the I is so that you can see how the code is running. So we'll say currently checking I, and you need to put the F here, otherwise the F string doesn't work. Okay, so if we run this, this is what we get, and let's do a little explanation. So for I in work essentials means we're going to loop through everything in work essentials. So we start off with laptop. Laptop is the first I. So at this point, we're checking for laptop, right? So we're saying currently checking laptop here because it's the first I. So that's what we're getting in this print statement. So if laptop not in bag, because the current I is laptop, so if laptop is not in bag, print that. However, it is in the bag. So laptop is in bag. So it skips straight to here and says laptop is already in bag. Then the next I, so what it does after it's done all the checks for the first I, it moves on to the next I in work essentials, the next item, which is charger. So now it's currently checking charger, right? If charger is not in bag, and yes, the charger is not in the bag, we need to, that's my typo here, we need to pack it. So it's alerting us that the charger is not in the bag, we need to pack it. And then after that, we move on to the next item, which is keys. Currently checking keys. Are the keys already in the bag? Yes. So that means that this check is failed. So instead we go straight to the else, which then tells us the item is already in our bag. And if we want to just make use of some of the stuff we learned about lists earlier on, instead of just printing it's not in the bag, we would say, okay, so our list is bag dot append I. So if the item is not in the bag, state that it's not in the bag, then to our list, which is our bag, append that item on the end so that it's now in our bag, basically. So here we can then print our like this. And if we run it again, you see now we've slowly added everything to our bag so that nothing is missing. Because whenever anything was missing, we appended it to the end. So charger was missing, so it got appended to the end of this initial list. So that's why charger is there. And then the last thing that was missing was phone, and that got appended on the end here. Okay, so let's move on to a football example. Here I have a bunch of Bayern or ex-Bayern players, and what we want to check is how their stats change after a specific match. And this is whether they score goals or get yellow cards for our example. So let's say in a match, those players scored and Kimmich and Davies got yellow cards, right? So the stats that they have are games played, goals, yellow cards, and after this match, this is what happened. So to start off with, to give us a good grounding, I want us to just print what everything looked like before the match. So how do we do that? Let's use our for loop again. So for player, comma, stats in player stats dot items print. Let's actually just print player and stat for now, just because there's a couple of tricky elements here. Okay, so what are we doing? We're looping. So this is a dictionary of dictionaries, not a list like we're dealing with up here. And you can loop through dictionaries as well. But remember, a list only has the element, but our dictionary has key value pairs. So you don't just loop through one of them. So that's why here, instead of just saying for I, do this, which is what we're doing in lists, you have to say for, I should probably do this to make it a little bit easier. For KV, so that's for key and for the value of that key in the items, print them. Okay, so what's our keys? Muller is the key because remember, it's like the word you look up. The data is like the definition. So Muller's the key. All of his stats are his values. So here we've printed key. Let's make it a little bit clearer, actually. Say this is the key. And below that, we'll say print is the value. And here we'll just print a bunch of lines, dashes, so that we can separate each print. Okay, so before the match, that's just what I happen to print here. This is the key, Muller, and these are the values for Muller. We should say this is the value for A. So that we're making it as clear as possible. Okay, so this is the key, Muller, and this is the value for Muller, for K is that. Then we go on to the next one. This is the key, Lewandowski. This is the value for Lewandowski. Okay, so now before the match, what we want to actually do is this. Okay, so we were using key value before. This is the same thing. I've just given them different names. For player stats is the same as for key value. In player stats.items, we want to print the player, so the key, and we want to print their games played, their goals, and their yellow cards, so we can just read it like that. So for key, Muller, we want to go inside his values. Remember, stats is V. And how we access items in values is we go into the value and we want to get the actual number of games played, which is what we get here. In the next one, let's say they had a match against Dortmund. And like we said, in that match, Muller, Lewandowski, and Sane scored, and Kimmich and Davies got yellow cards. So how do we do that? Okay. For each player, right? So for player stats. After this match against Dortmund, what's the first statistic would have to change here? Well, each of them has played one more game. So that's why we're looping through every player here. So for every player in player stats, we want to go into player stats and we want to find the key. So for every player, we want to then get their games played and say plus equals 1. It's weird syntax, but it just means add 1 to it. That's what we're just saying. I know plus equals, you usually don't see that in maths, but just trust me on that one. It's the same as saying add 1 to this. So we obviously will want to add an extra match played to each player, but we are also curious did that player score? So how can we check if that player scored and so that we know whether to add a goal to them? Well, that's where our if statement comes in. So we're still within that player. So now we can say if player in goal scorers, right? So if that player appears in this list of goal scorers, for that player, go into the player stats, find that specific player that we're looping through, goals plus equals 1. So we want to add a goal to them if they're in that list. And we'll add a print, our f string, and we'll say player scored. And then we want to do the same check for yellow cards. So a player in yellow cards, we want to go inside player stats for that specific player who we're looping through here. And we want to go into their yellow card stats. And add 1 to it. And we'll just print player got. So if we run that, we're updating and we start off with our first player is Muller. So what we're actually doing here is we're saying for Muller in player stats, go into player stats, look for Muller because that's the placeholder when we're looping through that list. So go into Muller, add 1 to his games, check if Muller is in goal scorers. Yes, he is. And then we get Muller scored. Check if he's in yellow cards. No, he's not. So then we just move on to the next player, which is Lewandowski. So now we're saying for Lewandowski in player stats, add 1, check if they're in goal scored, and so on. So now after the match, after we've run that code, we can do this, and we can see all of them have had 1 goal added to them, and the ones who have scored also have a goal added to them. Same with those who have yellow cards. So again, some of these concepts might seem a little bit tricky, but it might be your first exposure to it. Just play around with this code and see the different outcomes if you change and tweak different elements of it. Just use your print statements so you can always make sense of what's going on. I'll be real, if this has been your first time programming in Python, you've probably run into a bunch of errors along your way. And that's completely normal, but it also brings us onto the topic of exception handling. So what exactly is it? Well, it's a programming concept that allows you to deal with unexpected error conditions. So instead of your program just crashing, you can catch the error and decide what to do if you do get an error. So since we're in the realm of football, think of it like you were a football club who's trying to plan a transfer. Your plan is to buy a certain player, but you don't want it to cost more than half your budget. So if it was more than half your budget, that would be an exception, so potentially an error. So exception handling is how we would handle this. So just quickly, some of the reasons why it's important to exception handle instead of just letting your program crash. It allows basically graceful error management, which means your program doesn't just crash, it gets dealt with. So this actually leads to a much better user experience. And it's also really good for debugging because whilst you're writing your code, you can catch specific errors, then you'll know what exactly went wrong. So again, we've been speaking a lot in theory, so let's get hands-on and actually look at some code. So coming back to that example we're talking about, this is what it would look like with print statements. So if a player costs more than half of our budget, we would print it's better to save our money. But this isn't really error handling, this is an if-else statement. So I actually want to get stuck into error handling. So let's start off by looking at some syntax. This might look a little bit confusing at the moment, but essentially, whenever you want to do some exception handling, instead of just having our code just written out in our boxes like we have here, you always want to enclose that code in a try statement. So what this try statement is trying to say is exactly like it sounds. It's saying to Python, hey, try running all this code. But here is where we get to exception handling. Usually, without try, if you just had a bunch of code and there was an error in it, Python would simply just crash and say, there was an error somewhere in this code. But now with exception handling, what we get is try execute all of this code. But if there's an error, don't just crash. I want you to do this code instead. So try do this, but if there's an exception type, just don't worry about the specifics for now. If there's an exception type, an exception, do this code instead. So this code might be, it can be whatever you want it to be. It can be like, okay, print this nice error message, or it can be try doing this instead because I think this other method won't produce an error. And then you also have an else. So technically for exception handling, you only need the try and the except. But if you want to be more fancy, or if there's a reason in your code, you can also have an else where it's like, okay, if you successfully ran this code and there was no error, you didn't get an exception, then I want you to do this. So, for example, this code might just be checking that your data is structured the right way. And you're saying, okay, if it's not structured the right way, I want you to run this code of the exception. But if it is structured the right way, then come on to this next stage of the code. And then we have finally, which is this code always runs no matter what, because maybe this section of your code is part of a much bigger project and it's not crucial to the project that this code be executed without error. So it might be like, okay, even if there is an error, finally just continue and keep running the code anyway, or the subsequent code anyway, or whatever you decide to do with it. Might sound a little bit confusing now, but as we hop into our Colab notebook again, it's going to get a lot simpler. So this is just some code I had ahead of time. And what we want is to expand on our example of we don't want a player to cost more than half our transfer budget. So let's say we had a situation like this. You'll notice we actually forgot to set our transfer budget, right? And a certain player is going to cost £100 million. So what we're going to do is we're going to try to see that our transfer budget is more than twice the cost of the player, right? If it is, great, we can buy the player. If it's not, we want to save the money. So that's our if-else statement. So try to execute this. However, not having the transfer budget set is an unexpected condition, because if the transfer budget is none, you can't compare a number to none, if that makes sense. So for now, I'll comment all of this out and this as well. So what I've set up here is, okay, if something goes wrong, so except exception as E just means whatever inherent error statement that Python will print, I want you to just print that directly. So if we're to run this, what would happen? Because all of this is impossible because we don't actually have a transfer budget. So let's run that. So transfer planning with execution, with exception handling executed, that print is up here. So obviously because this produced an error, it's now just printing Python's own direct error message, which is greater than or equal to is not supported between a none type, which is our transfer budget, and an integer. So that's how that would look. However, in certain situations, you might anticipate, okay, I know the sort of error I'm likely to get. So this is a problem between the types of the data, an integer and a non-type. So this is called a type error. So instead of saying exception as E, we could be more specific. And don't worry about memorizing the types of error that you can get. As you get more familiar, all of this will become natural, but it's good to get an exposure to this. So you can specifically say except type error. So if we run into a type error, we know it's likely because the transfer budget hasn't been set. So instead of just printing this not so useful error message, you can imagine if somebody's not familiar with Python, they'll just be like, what does that even mean? We could print it in plain English and say, oh no, the transfer budget wasn't set. That's the exact issue. So now we can play around with this a little bit. What if our transfer budget was 150 million? We'll get to this condition because it is two numbers, so we won't get an error. And they cost more than half our budget, so we get into this phase. And then, like we discussed, we have an else statement, which runs if this runs without error. So we know that it's better off to save our money, but we want to thank the user for checking the budget properly before making a decision. And then this code always runs no matter what, whether there was an error or not. So it's thanks, we're basically just saying the transfer meeting has finished. Because no matter what happens, the meeting has to finish. So even if this was none, they would say, oh, you didn't set a transfer budget, and the meeting would still finish. So I don't want us to spend, 20 minutes just talking about exception handling, because this is something that you'll become more familiar with as you write code and as you get errors. But I just wanted to give you an exposure. Okay, now we're getting to one of the most interesting and powerful concepts in programming in Python, and it's genuinely a game changer. And this is what we call a function. And in programming, a function is essentially a reusable block of code that's designed to perform a specific task. And they're super important to running clean, efficient, and maintainable code that you want to run on a regular basis. So my informal definition is that it's a block of code that performs the same tasks without having to rewrite it every time. So sometimes there's something you want to do repeatedly and you don't want to write that code again and again and again. So you put it into what we call a function. So I know this demonstration is through the lens of football, but you're probably also a little bit familiar with tennis. And I think that this is the perfect example. So let's say you wanted to play a forehand in tennis. You could say, okay, these are the steps. Watch the ball, move your feet towards the ball, swing your racket back, swing your racket forward, make contact, follow through, return to the center of the court, right? And in code, that would look like this. So we're just using print statements. So all of this would be one forehand. And then when your opponent returns the ball to your forehand again, what would you then have to do? Okay. Another bunch of print statements just for the second forehand. And then they return the ball to your forehand again. What do you have to do? Another forehand. So you can see, even in terms of code, it's very messy and it's very long. You want to be able to just say play forehand, right? And have Python know that when I say play forehand, I mean run to the ball, watch the ball swing with your right hand, follow through, all of that. That would be much easier and much cleaner. And that brings us on to functions. So let's start with syntax. What does a function actually look like? So you always have to start by defining your function. And how you do that is literally through these three letters. Def. This basically signals to Python that I'm about to write a function, right? So it's def, and then your function name. This will be much clearer once we go into the code. So this is what, when you want to refer to the function later on, you use the function name. Between the brackets is what it takes in, and then you'll have a bunch of code in here, and then a return statement, what it returns. Slightly confusing, I know, but let's look at this in code. So let's think back to our tennis example. How would we approach this? Well, we would say def forehand, okay? Because we'll say def play forehand. Because instead of always having to print all of those different lines, we want to just be able to say play forehand. But what would you need to know to play your forehand? You would want to know the ball position, right? And the swing speed, for example, how hard you want to hit the ball. So once you decide those two things, you add a colon on the end, and then we can have our print statements again. So we want to say print, we use an F string, move to ball position, print, swinging racket back, print, make contact, print, And then we'll use another F string, forward, swing, and follow through at swing speed. Print, return to the center of the court. And then what do we want to return? Return is basically what you want the function to produce as a result of being executed. So sometimes later on in your code, you want to refer to whatever the result of a function was. So that would go in your return statement. But at the moment, we don't really have anything to return because these are just a bunch of print statements rather than playing with any data. So we'll just leave return blank. So now we can run this, right? So we've got our check, so that ran successfully. And now when we want to play our forehands, we can say forehand 1 equals play forehand, and then we must include these two things here. So let's say the ball position is right side of court. And the swing speed is fast. So you see, all I had to do was define this, and then everything else is in there. So we could say move to right side of court, so move to ball position, do all of that, forward swing and follow through at swing speed, which is fast. So that's much easier. And let's say we had our next forehand 2, we'll just say play forehand again, and we'll say the ball is short and center, and we want to play a drop shot, so we're swinging slowly. So then let me print a separator between these. And this is just to see where the difference between the two. And then here we have our second forehand. So you can see, imagine if in a match somebody plays like 100 forehands. Imagine having to write 100 of these versus 100 of these once you've defined it once. It's so much more efficient to do it this way because you're just repeating that code again and again with a couple of different conditions. So that's the whole point of a function. Okay, so let's bring it back to the realm of football. And let's say we wanted to create a very simple XG, expected goals calculator. So shots are something that happen pretty frequently in matches, and you don't want to be writing code for every single shot on how to calculate its expected goals. You want to be able to just plug in a few key factors and then get the XG of that shot. So let's walk through a very simplistic example of doing so. This is not actually how you calculate expected goals, but it's just for demonstration purposes. So we would define our function calculate XG of shot. And what factors do we want to consider? Let's say distance from goal, angle to goal, shot type. So what part of their body that they used, and then under pressure. So what we can actually also do is set some constraints on the type of data that we want to get in here. So for here, for example, under pressure, we want this to be a Boolean. Either they're under pressure or not. We don't want a string, because if it was a string, somebody might enter, oh, they're kind of under pressure, or they're sort of under pressure. But when you're writing code that won't help you because you won't have different conditions for kinda under pressure, sorta under pressure, and people might spell things or refer to things differently. So you want to, for this example, for under pressure, you want it to be, are they under pressure or not? So you want that to be a Boolean. So how you then constrain the type it can be is you just put a colon and then you put the type of data that you'll accept for that, which is a Boolean. Perfect. Now let's get to defining our function. And actually, just before that, we should do the same for everything else. So distance from goal, we want that to be a float because they can be 17.2 meters away versus 17.8. Angle to goal, that can be a float as well. Shot type will have to be a string. So then after that, we go to the next line, and our code for our function always has to be indented by 1. So when you press enter from here, if you're on the end here, it should actually just give you that indentation automatically. But if you mess up and you end up here, just press tab once. So now we would have to set up some conditions. So for distance, I've pre-written this because this is a lot to write. We'll say this. Oh, I've messed up my spelling. Okay, so we'll just change this to be spelt that way. Okay. So if they're less than 6 meters from goal, we want the base xg to be 0.8. So it can only be 0.8 or higher. And less than 12, so it can be more, it can be 0.4. Less than 18, but more than these, 0.2, and so on. Otherwise, if it's less than that, like they're shooting from the halfway line, the base xg, we'll say it's 5%. This is not how xg is created. I have to emphasize that, or calculated rather. This is just for an example. Okay, now let's say there's also an angle factor to it. So basically, if they're within 15 degrees of being front onto the goal, we basically don't want to factor in the angle at all. We want it to be 1, so the xg remains whatever it was. If there's 30 degrees or more of angle from the goal, so they're shooting more to the side, we want to multiply the base xg by 0.8 so that the xg gets slightly smaller, and if the angle is even bigger than that, we'll factor in 0.6. And then shot factor, if they're shooting with their feet, it shouldn't affect their xg. If they're heading the ball, it should be a little bit lower because it's harder to score with your head. And then I'm just tweaking some of the names up here because on my other code where I pre-wrote this, I named it differently. So we'll name that pressure factor. We still want that to be a Boolean. So if they're under pressure, we also want to multiply that xg by 0.7. So if they're under pressure, we want to multiply that xg by 0.7. If not under pressure, we don't want it to factor into our calculation at all. So how we then get it is by multiplying everything. It's very rudimentary, but we take whatever the base xg was, which is just simply the distance from goal, multiply it by the angle factor, the factor depending on the shot, and whether they're under pressure or not. And now this is where you see where we get our xg. We've calculated our xg. Sorry, this is where you see how a return works. So we want to just return whatever number we get from here. Okay, so that is our xg. And now let's say we wanted to calculate the xg for a bunch of shots. We've already defined our function here and all the variables that are taken in. And it's called calculate xg of shot. So for our first shot, he was 8 meters from goal, 10 degrees angle to the goal. It was a right foot shot and he was not under pressure. Versus shot 2, which was 22, 45 right foot, and so on. So now, instead of having to rewrite all this logic for every single shot, all we have to do is plug this in over here. And then if we run this, we get an instant calculation of the xg. So look how short this code is. It basically fits on one screen for me. Versus if we're doing this without functions, it would look like this. I couldn't even be bothered to type all of this. I had to get like ChatGPT to be like, could you give me the non-function equivalent? And you can see this is just shot 1. We get all our factors, then we have to write all those if statements. Then we get to shot 2, and we have to do the same thing all over again. It just doesn't make any sense, and we're still scrolling, and we get to the end. It gets you the same thing, but it takes you much longer to get there. So think of everything that we've been learning so far. All of that code, if we wanted to, we could put it into a function to achieve a certain goal. And I think now you can begin to sort of extrapolate the value that functions give us. So instead of just going straight through this video, I want you to take a moment and really absorb and maybe even play around with some of the concepts that we were doing before and see what sort of functions you can come up with and how accurately you can write the code and understand what you're doing. Again, this is a lot to be learning all at once. So if it does seem a little bit confusing, it's not because you're dumb. Coding just takes a little bit of time to get adjusted to. So really take your time with this. What we're about to discuss is probably the most important aspect of football data science, and it's a skill that can help you do the simplest thing in Python to just help speed up your workflow, or it can help you build a machine learning model that could change the world of football. So what we're about to talk about is libraries in Python. So imagine you're a football analyst who needs to create detailed match reports and player statistics. But instead of just analyzing the data, you had to build the entire analysis system from scratch. So in that example, you need to code a way to read a spreadsheet, a system that calculates averages and percentages, tools to create charts and graphs, a method to handle missing data, stats functions, all of this different stuff, right? It sounds, well, it is pretty much impossible. So what would you actually do instead? You would probably just put that data into Microsoft Excel, right? Because somebody has already made that system that can read spreadsheets. And you would be able to just focus on doing the actual analysis. So these pre-made platforms like Excel and what have you are sort of like Python libraries, because Python libraries are essentially huge chunks of code that somebody has already coded for you ahead of time to do fairly common tasks so that you don't have to do them yourself. So like in our example, looking at data is fairly common. So somebody built a software like Excel that does that for you so that you don't have to reinvent the wheel every time you want to do that. So a quick example is if you wanted to calculate standard deviation, you could write the function and the formulae and all the code yourself, right? But it turns out that somebody has already written code to calculate standard deviation because it's such a common thing to do. And how you do that is you would import the statistics library, statistics, and then let's say these were Rashford's shots. So let's do this first. We could then say calculate the standard deviation of Rashford accuracy, and we'd get our answer, right? But we had to write all of this. Or we could just go to the statistics library and just say statistics dot stdev, which is standard deviation. And then we'll just plug in those same numbers and we get pretty much the same answer. My formula is probably slightly wrong or something's been rounded off somewhere, but it's essentially the same. So this was a lot of lines to reinvent the wheel versus we know somebody already made a library called statistics and we want to look for the standard deviation within there. How do you know which library has what? You sort of just explore. So when a need to sort of look at these statistics, comes up, you'll probably just Google or ChatGPT, what library do I use for this? And it will tell you what libraries to import. I just knew that this is the one you use for standard deviation, or one of many. So don't worry about that part too much. Okay, so let's get a little bit more formal with our definition. A library is basically a collection of pre-written code that other programmers have created and shared that you can use in your own programs. And essentially you use them to save time from having to rewrite everything. And also for accuracy, you saw my function produced a different answer. Mine was probably wrong, but if somebody has, spent hours creating that library, they've definitely double-checked their work. So it improves the reliability of your code because you're using what somebody else has already validated. All of this is going to allow you to focus on your actual goals instead of reinventing the wheel. So in terms of types of libraries, we have standard libraries that come with Python. So you can see with statistics, all I did was just import it. But sometimes you have third-party libraries that you have to install onto your Python version. And we're going to get into that later, but it's just good for you to know that there's these two different types. So what you need to remember is that whenever you use a library using this keyword import statistics, you're basically telling Python, hey, I want to use some of this pre-written code to do a specific task. So here, Python has actually imported all of this pre-written code that you can see over here. If we hover there, and by saying library.stddev, we're saying from this pre-written code, we want the function that is called stddev, which is standard deviation. So actually, if we hover over statistics, and then we scroll down, we'll see there's all of these different functions in here that can be called. But the one that we want is this one here, stdev, which is a simple standard deviation of data. And it's in there already. So we said, okay, go into that code, give us back that function, and for these numbers, execute that standard deviation function. So this whole video is assuming you're a beginner, and for our use case, the three most important libraries we're going to talk about are Pandas, which is good for looking at data in spreadsheet format, NumPy, which is good for any math calculations, and Matplotlib, which will help us create charts and graphs. So let's talk about using Pandas to start off with to get used to using libraries in practice. So at the top of programs, you usually see statements like this, which is pip install pandas. So remember how I said some programs come built into Python, like statistics, and there's sometimes more specialized third-party libraries that you need to bring in from elsewhere. So that's how you install it. So just like how you would install a software from a website, because we're programmers and we don't want to have to go onto a website and do all of that, this is the easy way of doing it. So the caveat here is I think Pandas actually does come with Python, but this is just a good example to show you how it works. Because we're working in Google Colab, we have to put this little exclamation mark before we say pip install pandas. But when you eventually graduate out of Google Colab and move to VS Code or Cursor or whatever, to install libraries, you don't have to put the exclamation mark. It'll be more like this. But for our use case, we have to put it there. And you can see it's working away, checking it's downloaded. As I said, it comes with Python, so that's why it says requirement satisfied. Usually, if you're installing a different library, like let's say, I'm pretty sure there's a football library called Kloppy. Yeah, so you can see it literally just downloads it here, super quick, and it's already been installed. But we won't be using it today, so we'll stick with Pandas. So now that Pandas is installed, we then import Pandas and we run this. Cool. So the famous Pandas is ready to be used. So why is Pandas such a big deal? It's probably the most important library for you as a football data scientist, and it actually has a bunch of uses that we're going to look at. But what we need to first understand is what a Pandas data frame is. The simple way of thinking of a Pandas data frame is like a spreadsheet, but specifically for Python. And you might be wondering, why do we use data frames? Well, it's actually the same reason we'd use any other tool like Excel, because it has so many uses and it's good at doing so many things that we need as a data scientist. So, for example, it's really efficient at handling large data sets. You'll notice all the examples that we've been doing before are like written on one line. We're writing lists, we're writing dictionaries, but usually if you're working with a data set in real life, it will probably be somewhere else like a CSV, and it will be a lot of data, like minute by minute data. Pandas allows us to load all of that. And In a data frame, just like in an Excel spreadsheet, you can handle data of many different types. So you can have strings in there, you can have ints, floats, and it's just a lot more flexible. Why so many people like using Excel is because it makes data manipulation so easy. So you can get your averages, your means, your standard deviations super easily, and basically it's just a really powerful data tool for our use case. Okay, so what does a data frame actually look like? I have a little sketch for you here, and as you can see, there are three main elements. So what we have, just like in any other spreadsheet, is that we have our index here, which is the actual numbers going down the side, and our columns, which is the letters that go across. But for our use case, our columns don't have to be letters. We could name them whatever we want. And then the third element is the actual data that fills the section. So these three can work together. So for example, if I wanted to refer to this cell here, to the data in this cell here, which is the first thing, I would use the other two elements, which are the index and row, to refer to it. So I would say the data that I want is in column F at index 2. Pretty straightforward. So how do we actually create a data frame? To be honest, there are a ton of ways. So one simple example I've got for us here is making one just from a dictionary. So the advantage of using a dictionary is that when we create the data frame, the key will become our column name, and then everything within our list in this case, since we want more than one row, would be part of the actual data. So what we'll do is we have Bayern players, which is this dictionary here, and then to turn it into a DF or a data frame, we would say, well, here we would actually say pandas dot data frame Bayern players, like that. And then now we can display that data frame so you can see what it looks like. There you go, and we've got our nice little table there. So now you're beginning to see why I say it's literally just like an Excel spreadsheet. So our four keys were player, position, goals, and age. And they're now here, player, position, goals, and age. And then the relevant data is going down within the columns for each of these. Something I should mention is that usually when you're dealing with a library such as pandas, it won't just be import pandas like this. Usually people say import pandas as PD. And what that's called is aliasing. So basically you're just giving this library a nickname. So you wouldn't want to type out pandas every time you wanted to use a function from the pandas library. It's much easier to type 2 letters instead of 6 letters. So if I ran this and then I ran this, it would give me the same answer. All I'm saying is just whenever I say PD, I mean pandas. So because data frames are so important, I want us to do a little walkthrough of some of the key features and the key operations that you can do with data frames. So the first thing you might be wondering is how we can access the data within our data frame. So the answer to that is it depends what you're trying to access. This data frame could potentially be millions of rows long. So let's say we just wanted to get the player names from the data frame. How would we do that? Well, we would first need to tell Python that we're referring to the data frame. So we'd start by putting Bayern DF so it knows this is what we're talking about. And then using square brackets, we can then select the column that we want to interrogate. So what we want to look at is players, or player rather. So I would then open my quotes and then I would just select player like this. And then it would return just that column. But sometimes I might want just the players and the age, because maybe I'm trying to judge my squad to see what positions need a little bit of refreshing. So if you want to refer to more than one column, what you need to do is put the columns that you're referring to in a list. So you have your square brackets that tell you you're selecting a column, and then you want your 2 or more columns within a list. So it ends up being 2 square brackets. So the syntax would actually look like that. And then within this list, I would then pick my columns. So I want player and age and nothing else. Because you can imagine you might have a spreadsheet that has 200 columns, and most of those might be useless for what you're trying to do. So instead of having to try and scroll across and see what refers to what, you can just isolate the specific columns that you want. But perhaps you want to isolate the data frame and filter it so that you're just looking at your forwards. You want to look at what your forward line is like. So how would you do that? Well, I want to store the forwards, right? So I could give it a variable name. And again, we always have to tell Python that we're referring to that data frame. And again, our good friend is the square bracket. So if we're trying to isolate the forwards, what are we trying to do? We're saying, okay, return me this data frame, but look at this position column, right? So what we would then do is, okay, look at, the position column. So this looks a little bit weird, right? Like, why do we have the data frame twice? Okay. If you remember what we did up here, let me make this a little bit easier for us by doing this. So this looks like we're referring to the data frame twice. But remember, if we isolate just this part, this isn't a data frame. This is a column in a data frame. These two are the same thing. It's just a column. So we're saying in the data frame, look at this column, and from this, and we want you to return this data frame, but only where these columns are forward. So remember our double equal sign from Booleans? So we want where forward is true. So is forward true here? Yes, yes, no, no, yes. So if we do this, that will give us our correct answer. Because we said, okay, our data frame, find this column position, and only return the ones where it says forward. So the thing with code, if it begins to look a little bit complicated like this, just like we did here, you can begin to break it down into pieces. So if you're like, okay, I know that column means that, but what happens if I just copy paste just this section? What exactly are we saying? And then you see, for each of these, it's a Boolean statement. You're asking it, is this equals forward, true or false? So we get true, true, false, false, true, which is why it only returns where the 3 rows are true. So that's how you select specific rows. And in a similar vein, maybe you only want your high scoring players who have over a certain number. So again, we select our data frame, we select the relevant column in our data frame, and we want goals, and let's see what our data looks like. Okay, so we'll say anybody over 10 goals. So we say goals greater than or equal to 10. Please return that for me. And there we go. Only people with over 10 goals were returned. So let's come a little bit further down. This spreadsheet is great, but what if we wanted something else? Let's say we have goals, so what if we want assists as well? How do we add this column? The beauty of Pandas data frames is it's super easy to do so. All you would have to do is put your data frame name, the name of the new column that you want. So, quick little note. So this means select that column. However, if you put a string there that is not already a column, this means add a new column. So here I'm basically saying add a new column named assists, and we need to have the same number of assists as we have number of players. So 5 players, so we'll say 8, 5, goalkeeper presumably 0, 12, and I don't know, 7. And then if we then display the data frame below that, there you go. Easy as that. We've added our new column. So how would we add a player? Let's come to this new row. Again, we have to define our data frame again. And what we use is LOC, which is sort of like location. So remember our index here, 0, 1, 2, 3, 4, which is like those numbers that go down the side in our Excel spreadsheet. We want to add someone below Mane who's at index 4. So what we would just then do is locate index 5, and then we would add in our new player and make sure he has the right number of statistics. So what do we have? We have player name, position, goals, age, assists. So how that would look could be something like this. Again, you see we've added our new player there. And then to drop a column, it's pretty easy because all you have to do is state your data frame. And then you want to drop a column. So what does drop mean? Well, the more you work with data frames, you'll start to know what the keywords are and what functions you need to call. But if you hover over it like this, you can see that a little description of what it does. It drops specified labels from rows or columns. So here we want to drop the assists column because maybe we just don't need it anymore. And you just put axis equals 1. And if we run that, you'll see when we display it, it looks like that. We've gotten rid of our assists. And we could just as easily get rid of a row. So here we specified that axis equals 1. This is basically telling it remove from columns from the column section. But by default, axis is equal to 0. So if you want to actually drop from, let's say we want to remove Sane, we don't have to specify that the axis is 1 because by default it's 0. So we don't have to specify that the axis is 0 because by default it's already 0. So we just say 5. From it, we use the index number. There you go. Our DF is exactly what it used to look like. So again, imagine if our data frame was absolutely massive. We might just be looking for a quick way to get an overview of the data and the statistics. So the good thing is that Pandas actually allows us to do some data analysis pretty quickly and pretty easily. So one of the most useful methods is the .describe, which I will show you now. So if we just do our data frame .describe and print that, you'll see we have some figures here. We have count, which is just the number of rows, the standard deviation of our numerical fields, so goals and age, and a few other stats, the 25th percentile, 75th, and the highest number. So for example, the oldest person is 37, so we've got 37 there. The highest goals is 35, so we have 35 there. So it's just a good way to get a quick, easy overview of specific numbers. But at the same time, just like how in Excel, at the bottom of a numerical column, you can ask for the average. We can easily do the same thing with our Pandas data frame. So let's say we wanted to just have a look at the goals. What are the average goals scored by our team or our players? We could just say goals and then .mean. And we'll get our answer, which is 14. So this is just NumPy float 14. So again, that really important thing I want you to learn to do is break the code apart. Usually if you see a dot something here, this is just a function that is being applied to the result of whatever this is. So what we could actually do if we want to break this down is, let's just do it step by step. Okay. So bind df alone, that just means this whole data frame. If we then add this, that means just this column, right? So now we're just saying get me the mean of just this column, which is how we end up here. Something else that's super useful in Pandas is the group by operation. So imagine if we didn't have data for just Bayern Munich, but let's say we had data for every Bundesliga club for the last 20 years. So that would be thousands of rows, hundreds of thousands probably. And we just wanted to answer a simple question like, what are the average goals scored by a forward in this league? So unfortunately, I actually don't have that massive spreadsheet for you. So what we will use is just our Bayern data frame. So what we would say is, okay, Bayern data frame, group by, and now we're picking what column we want to group by. So here we're grouping by position. So it's going to be getting these three together, the midfielder and the goalkeeper alone. And then for each position, we want to get the goals. I'm curious what that gives us. Okay, we want to get the goals, and then we want to get the average of the goals for each position. And there we have it. So for the forwards, the average is 20.6, which looks about right. And then we should have 8 on the dot because there's only one midfielder, and 0 on the dot because there's only one goalkeeper. So as you can see, when you have massive scale data, it's just so much easier to manipulate this data now. So that's why pandas are essential, or pandas is essential. So there's a lot of other things you can do with pandas, like merging 2 data frames together. You can handle missing data, but what I want to focus on, so those are just branch off topics for you to look at. What I want to focus on is when you do actually have a CSV file. So the link to this CSV on Kaggle, I'll leave it in the description below. But what I'm going to do is upload the stats CSV. And how you do that is you click this. So we were here, let me just show you. We were here before. I clicked this here. That's the table of contents, which is just basically everything we've been writing as we've been going along. Come back to the bottom. And we don't want that. We want files and folders. So here we could click upload, or I can just drag my CSV into here. Just say okay to that warning, and as you can see, my CSV has been uploaded here. So now I want to show you the beauty of pandas is that you can easily just, before we use that dictionary where we wrote out the data, in real life, you'll rarely ever do this. What you'll usually be doing is sourcing your data from somewhere and then bringing it into your code. Okay, so how we actually have to do this is we need to import the library called Google, which was obviously made by Google and allows you to do stuff in your Google Drive, which is essentially where Colab is. So we'd say import google.colab. Actually, no, we want to say from google.colab. Don't worry too much about this syntax for now. You'll get used to this if you work in Colab a lot. Import drive, and then you have to mount the drive. And it's content/drive, and then you run that. I've just run this just before this actually. So when you run it, it might ask you to confirm a bunch of things. Just say okay. I think it's like 3 different windows that pop up. Just say okay to all of those. And then now we already have pandas imported, but let's say we're at the top of our script. We'll do import pandas as PD. And we want our data frame to be whatever is in this stats.csv. And the beauty is it's as easy as saying PD dot, because we're saying from pandas, I want to use the read CSV function there. And then we open brackets, and if you hover over this, again, you'll see a brief description of what it does, which is just allowing you to read the CSV. It's a lot of text, don't worry too much about it, but we will then say R. And what you can do here is if you right click this and say copy path, and then paste that in there, and then you run that. Easy as that. So if we now do that, you'll see we have this massive CSV. Well, it's not that massive, 240 rows, but a bunch of columns. It gives us a lot more data than what we're just working with. And again, now you see where it gets a little bit tricky because there's so many numbers here. I don't want to be individually seeing what's in this data, or like visually inspecting, I should say, what's in this data frame. So this is where that .describe could be really useful, because I can just do this. And just from doing that, I have an idea of the average number of wins by a team, average number of yellow cards, the maximum number of yellow cards for a team was 9. And you now see the power of .describe. It just gives you a bunch of summary statistics. At the same time, if I wanted to, is this a single season? Oh no, actually it might be many seasons. So how I can check this is by seeing if there's any team that appears twice. Okay, so let's say I want to check if there's many instances instances of Manchester United. How would I do that? Okay, so my df is that. I want to go into the team column, and I can use this function called value counts, which just tells you how many times something appears in a certain column. And we can see Manchester United appear 12 times. So obviously this is over many different seasons, which makes sense, as we can see over here. So now let's use that group by in a more useful way. So let's say we wanted to see the average number of goals for Manchester United only per season, right? What we could then do is say, okay, our data frame is df, right? And we want to use our dot group by, and then we want to group by the team. So actually this won't just be Manchester United, it will be by team instead. And we want to look at the average goals for each team. Okay, so you can see we do have the averages for each unique team, but I want it in order. So if you remember our dot sort values, this would then just basically sort by ascending or descending. And I believe by default it's in ascending order. So Derby County, I think they were only in the league once, I think their worst season. So you can see on average, the two Manchester clubs score the most goals, but it's pretty even over time. And all of that was just done with a pretty simple one-line piece of code. And the last thing we want to do is how to write a data frame. Let's say you do a bunch of data manipulation to your data frame, and now you want to save your new data frame as a CSV. How do you do that? Okay, so let's say we want to save so let's say now we want to only look at Manchester United. So again, if you remember how we filtered down a data frame, so we're saying, okay, in our data frame, go to this column, and now I'm saying I only want where the team equals Manchester United in that column. So if we call that MUFC like that, this should work. There you go. So you see we have the different seasons from 06-07 to 17-18, and it's only Manchester United. So now it's only 12 rows. And we want to save this now. So again, we use pandas. So it's your data frame, which is our Manchester United data frame, .to underscore. So here we have all our options. I could save it to CSV, to Excel, as a dictionary, all this different stuff, but we want to save it as a CSV. So it's pd.tocsv, and then we'll just say Manchester United only. And this is very important. You have to put the file extension .csv, and that will get saved as a CSV here. So we now have it here, and then if I wanted to, I could download it locally. Again, I want you to play with pandas and really get familiar with it, and it's super useful and super powerful, so I advise you to take your sweet time in getting well acquainted with this.
So just like with pandas, in Google Colab, NumPy comes pre-installed. But if you ever need to install it elsewhere, you just use the same command, pip install NumPy. And the most common nickname for NumPy, just like for pandas, we imported pandas as PD. For NumPy, it's as NP. So you can see even it's so common that even the autocomplete is ahead of it. So as you can see, requirement is already satisfied because, like I said, it comes pre-installed. But what do we actually use NumPy for? As a football data scientist, you'll be doing a decent amount of math, and NumPy is key to making all of that a little bit easier. And the hint is in the name. NumPy stands for numerical Python. And really the backbone of NumPy is what we call an array. And an array is a way to store a bunch of items in an organized way. And you might be thinking, wait, isn't that what lists are for? And yes, there is some similarity between lists and NumPy arrays, but there's also some key differences. So we'll just go through the differences between them, and before getting into why NumPy is sometimes better to use. So we're going to start with what is called a 1D array. So think of it like this. If we had a list of Son's goals, it would look like this. And actually, like I said, the 1D array is pretty similar. So if we say NumPy Son goals, what we do is we say NP, which again is our alias for NumPy, dot array, and then we chuck it in a list within that. And again, they do seem pretty similar, but if we print their types, you can see that they are different types completely. So one of the key differences is that with lists, all of these elements can be completely different. So for example, we could potentially have something like this. So I'm not going to walk through the syntax exactly of what's happening here, because with everything we've covered, you should be beginning to understand what's going on. And if not, just take a pause and see what's on screen and see if you can figure it out yourself. But anyway, you can see that each one of these is a different type of each one of these is a different type of data. But with a NumPy array, if we print this, you can see that everything has been converted into a string. Because whenever you're dealing with NumPy arrays, they all need to be of the same type. So either all an int, a float, or a string. So here, because there's a string in here, it has to convert everything to strings because it can't convert them to anything numerical because we have these two things in here, which are not numerical. So it's a really good way of enforcing data consistency because maybe further down in your Python script, you have something that requires the data to be of a certain type. If you use a list, there's a chance that the data might get converted at a certain point without you noticing, and you get errors further downstream. Whereas with NumPy, you know it will always be of that same type. So like we discussed in Python, you can have a list of lists. Let's say if you wanted to separate out player names from their goals and assist contributions in different matches. And in NumPy, you can do something similar. But instead of being called a list of lists, it's called a 2D array. And in terms of the setup, it's very similar, except we obviously use NP array over here, and we're not using two square brackets. We have a regular one and a square one inside, but it's basically the same thing. So we're going to get into why it's better for mathematical operations in a sec, but I just want to discuss how we access elements and the differences between the two. So if we wanted to know in this second list, so remember we saw the index 0, if we wanted to know in the second list, how many goals did the second person score, which happens to be Richarlison. How we would do it with lists is you declare that you're looking at this list, and then you say you want to go into the first element, so 0, 1, and then you want to go into the first element as well within that, so 0, 1. And the syntax is slightly different for NumPy. So how we would do it this way is we would, again, um, select our NumPy array, and then we don't have to put it in separate square brackets. The logic is pretty similar, but how you do it is just this. So this tells it go to index 1 and then look at 1. Basically, it's just a slightly shorter way of doing it. You can also interrogate the data a little bit more easily. So if you wanted to check how many elements are in this, instead of using the length argument like we do with lists, what you use is dot shape. So NumPy array shape, and then again, you select your NumPy array and you use dot shape, and it will show you that there's 3 elements row-wise and sort of 3 going up, if that makes sense. So 3 rows, 3 columns, which is what we have here. I want to get into more of the mathematical elements now. So let's say we had a list within it, so a list of lists with goals. So let's do this and say 1 goal, 0, and 2. And then the next list is 1, 2, 1. And at the same time, let's do the same thing, but as a NumPy array. So NumPy, there we go. So let's say we wanted to add up all the numbers within this list. How would we go about that? Well, could we do this? No, we couldn't. Because remember when we do addition of two lists, all we're doing is concatenating them into one big list. So how would we do this? We'd probably have to do some sort of for loop. So we could start by saying, okay, for I in list goal, let's just print I so we can see what that actually is. So each I is a list. Okay, so we want to go within those lists and sort of add them to the total. So then we can make a for loop within a for loop for list uh, or list in sublist. Now for list in I, and let's just print. I think I should have said list element actually, because then you can see we're printing the first I, which is that, then each of the elements, then the next I, which is that, then each of the elements. So what we can actually call this to be more accurate is element for list in list goals and for element in I. So for each of those elements, total equals total plus whatever that element is. And then we would want to display the total. So we'll put it down here, which is, let's be a little bit tidier, take out the print statements. But basically, you'd have to go within each list, and then within each list, add each number to the total, like we see over here. And eventually we'll get to 7. And contrast that with NumPy, which is actually designed to work with numerical figures. What we would get instead, how we would get this instead is by doing this. We'll get NumPy goals, and all we'll have to do is total is NumPy goals dot sum x's equals 0. Sorry, I just made an error there, so we don't need the axis. If we just erase that, then we'll get 7. So compare having to write nested for loops to literally just putting sum. It's a lot easier, right? And that's not all. Let's walk through a couple more examples. So here, let's say for every element in this initial list, we wanted to add 5 to the total or to the number. How we'd have to do this is make a new list and then write a for loop for every element in the old list. We want to add 5, then we'll get 6, 7, 8, 9, 10. Compare that to a NumPy array, where all we need to do is simply add 2 characters. So we have our NumPy array, which is similarly defined, and all we have to say is +5. And because the whole library is designed to be working with numbers, it already knows that means just add 5 to everything. And it's the same thing with other mathematical functions. So again, let's say we were looking at a Python list and we wanted to get the average. How we would have to do this using lists is this. So we'd have to sum the list, right? And then we would have to get the length of the list, i.e. the number of elements within the list, and then divide them. And that's how we'd get the average. So if we display this, now compare that with a NumPy array, where it's just NP array, so we define our array, and all we have to do is say dot mean, because it knows we're working with mathematical figures. So already you begin to see the potential power and why NumPy is important, because it's designed to work with math. Again, NumPy, just like pandas and everything else we've looked at, it's so vast and you could spend hours and hours looking at it. So this is just more of a primer. I want you to dig deeper after this video and see what else you can find out about NumPy. Okay, so picture this. You just finished analyzing Manchester United's passing data from the last season, and you have the spreadsheet full of numbers. Pass completions, progressive passes, defensive actions, everything. The insights are there, but they're buried within this spreadsheet. So how do you make sense of it? And how do you communicate what you found to whoever needs to make tactical decisions for tomorrow's match? This is where data visualization transforms everything, because we as humans are very visual creatures. And football generates an incredible amount of complex data every single match from player movements to pressing intensity changes throughout the 90 minutes. So it gets really tricky to visualize that using just numbers. And numbers can't really tell the complete story sometimes in a way that fans, coaches, and other analysts need to understand. And that's why visualizations such as heat maps, touch maps, rolling XG charts, all of this sort of thing are super popular because they communicate an incredible amount of information very quickly. And in that regard, there are two libraries which are essential for you when it comes to visualization. The first is Matplotlib, and the second is Seaborn. They do pretty much the same thing, but we're going to be concentrating on Matplotlib. So what is it? Again, it's another library, but this one allows you to make a bunch of different charts and visualizations in Python. And what makes Matplotlib so popular and so powerful is that it's very versatile, as it can make charts of almost any type. You have control over the coloring and the fine-grained details of any plot, and it works well with what we've already been using, like NumPy and what have you. So at this point, you should be quite well accustomed to installing and importing a library. So it would be pip install matplotlib. Just like that. I run that. And you can see I already had matplotlib installed, but it doesn't hurt to just do it or to just double check. And then now we would need to import matplotlib, but we specifically want Python plot. So it's just .pyplot, as PLT is the usual shortcut. Just like how pandas is usually PD, NumPy is usually NP, Matplotlib is usually PLT. And then you just import NumPy as NP because we're going to use it to generate some numbers. So I have some code ahead of time so that we don't have to sit here and watch me type. So the easiest way to get used to working with libraries you're unfamiliar with, like Matplotlib, is just by reading the docs. If you just Google it, you'll be able to find them. So just like here, all I did was Google Matplotlib docs. And then if you click in there, you basically have a little quick guide that will show you the different sorts of charts that you can make. But that's basically what I'm walking you through right now. So let's say we have a player's goals per game, and we wanted to create a line graph of the game number versus how many goals they scored. How would we go about this? Well, I'll just run that and run that. So because we're using Matplotlib, we would have to call PLT, and what you use is actually plot. That's what lets it know that you want to plot something. And then what do we want to plot? Our goals per game. Per game, and we want to use a little circle to mark where exactly the goals are being scored. So if we did that, that would run, and you can sort of see it beginning to take shape because we can see in game number 0, because it's 0 indexed, it was 2 goals. Game number 1, which is in between here, it was 1 goal. 2 was 3 goals, and what have you. But this is still a little bit difficult to interpret because firstly, we actually don't have a title here. So what we want to do next is say PLT dot title, very intuitive. And what do we want our title to be? Goals scored per game. And then if we want that, we now have our title. It looks a little better. It's beginning to come together. But what we don't have down here is what are these? Okay, those are the game numbers. So we want to label our x-axis. So it's x label and then open brackets, game number. A little better, but what we're still missing is our y label. So plt.y label, and that is goals scored. So we can see this is coming together now, but it still looks more like a scatter plot than a line graph. So here we only said that we wanted a circle, but we need to be able to connect those lines to make it look a little better. So how we do that is a hyphen. And once we add the hyphen, those lines get joined up. Technically, you could do it without the circle, but it just means that the actual goal scoring points wouldn't be highlighted. So that just looks better. There we go. So that just looks better. So just like that, we have a nice line graph in Python. And as you can see, that wasn't complicated at all, super easy. All you have to do is sort of memorize or even just look up the syntax whenever you need it. So the next thing I just want to show you here is sometimes you want to put two charts next to each other, right? So let's give an example. Let's say we wanted to compare two bar charts next to each other on the same image. How would we go about that? So you can see now it means that we have two empty plots. So now we actually need to plot our data. But the important part is that we can see they're next to each other. So how do we go about this? Well, remember how we said we want the two subplots on axis 1 and axis 2? So this is axis 2. Sorry, this is axis 1. This is axis 2. So we specify which axis we want to do our visualization on. So now we want to do a bar chart. And it's similar to how we did things up here, where it plt dot plots there. But here we're specifying we want a bar chart. And we want to compare our home matches, the possession in our home matches. And for home, we'll say the bar should be the color blue. Yeah, I will leave it like that for now. So if I run this, whoa, and then the issue is I need to do this for both of them at the same time. So if we want to say axis 2 bar, and that one will be away matches. Away was the possession. Yep. Possession. And we want away to be red. There we go. Just need to pop in the color there. So now you can see we actually have our two charts comparing the home and the away possessions. But again, a chart without being labeled on the X, Y, and the title is pretty much useless. So what we do here is, and the other thing is, we can see they're of different scales. So this one only goes up to 50 because the highest possession in the away match was what, 48? Whereas this one we got up to 60. So they're at different scales. So what we do to fix that is we set the limiter on the y-axis. So to save a little bit of time, I'll just copy and paste across the code so that you guys can see what it's supposed to look like. So here is where we set the y limit for the first axis. So you can see this one is going up to 100 now, but we still have the same problem here because we haven't told it has to go up to 100% yet. So we just copy paste that there, axis 2, and we've added our titles here. And now they're at the same axis, so you can actually make a direct comparison. So there's plenty of different charts, and here we showed how to put two charts side by side, but you can actually get more complex and let's say have 4 charts in a bit of a grid format. But I want you to explore how to do that because it is literally impossible for me to teach you everything about Python or for you to actually know everything about Python because nobody does. It's such a vast programming language. So the key is curiosity. So with this video, I've given you the basics. I want you to revise it and make sure you've understood it. If there's anything you don't understand, the comment section is right down below. And also you can just look around online if you ever need any guidance. But yeah, I'm open to answering questions down below. So now you know the basics of Python to be a football data scientist. There's plenty more content about the football data science life coming up. If that sounds interesting to you, you already know what to do.